Today we're going to be looking at some trigonometry, and more specifically, we're going to be looking at trigonomic ratios in some SAT questions. So the first questions are pretty easy, but I will be going over them. And so yeah, feel free to pause and see if your answers line up. Okay, in triangle ABC above, what is the value of sine B? So we know so, ka, toa. And this is something that is very important for trigonometry. These are the fundamentals for ratios. So it says, what is the value of sine? So we will look at S, which is so, and O and H means opposite over hypotenuse. So sine of anything, say theta, equals opposite over hypotenuse. So we know sine of B, which is in replacement of theta, we look at here, opposite over hypotenuse. Now we don't know the hypotenuse, so how do we figure out the hypotenuse? Obviously we have the Pythagorean theorem. So if we do 2 squared plus 5 squared equals c squared, we can get 4 plus 25 equals c squared, 29 equals c squared, and square root. We just use the positive value because a side length cannot have a negative value, so we get c equals square root of 29. And so now we have the square root of 29 in replacement of the hypotenuse. So we have square root of 29. And so it will be opposite over hypotenuse, which would be 5 over 29. Square root of 29, which is c. In triangle ABC above, what is the value of cosine B? So this is the same thing. If we just look at B, we do need to calculate the hypotenuse here. So we do 4 squared plus 6 squared equals c squared. We get 16 plus 36 equals c squared. And so we would get 52, I believe, equals c squared. Square root of that, both sides. C equals square root of 52. So opposite is the value of cosine B. It would be cosine is actually right here, which is adjacent over hypotenuse. So it'd actually be 6 because it is adjacent to the angle. So it'd be 6 over 50, square root of 52. But as you can see here in the answer choice, they don't actually have an option choice for that. And so that would mean we need to simplify the square root of 52. And how do we do that? We can do prime factorization to factor out square roots. So what we do, we find the smallest number, smallest prime number in 52. And smallest number every time you start with is 2, because 2 is the smallest prime number. And if the number inside the square root is even, you can always divide by 2. So if we divide by 2, we get 26. Same, because it's even, we can do 2 and 13. And because 13 is a prime number, we stop there. That's very important. And now this is the important part. You would group two pairs together, all right? And because there are two 2's, that would become 1 2, and it would come outside the square root, and you would just plug 13 back here. And let's say, for example, if we had 208, and we did that, 2, 104, 2, 52, 2, 26. If we had it like this, we would have to group these two, and then this would become 1 2, this would become 1 2, and what you would do is just multiply them, so that would become 4. All right. So 2 rad 13 is the number on the denominator, so it'd be 6 over 2 rad 13, and 6 and 2. You can divide 6 by 2 and make it 3 over rad 13. So that would be B. Number 3, in triangle ABC above, what is the value of tan C? So now, if we bring SOHCAHTOA, TOA, we have TOA for tan. And it's opposite over adjacent. There's no hypotenuse involved. So tan C, we can see here, opposite is 2.5 over adjacent, which is 4.5, 2.5 over 4.5. Which is also equal to 5 over 9 if you multiply both sides by 2. Number 4. All right, so these are the free response questions, and these can get a little difficult because you don't have 4 answer choices to look at. So in triangle FGH, the measure of angle G is 90 degrees, and FG is 3. If tan F equals 4 over 3, what is the length of FH? So that's a little confusing, but what we'd like to do whenever they say in triangle FGH, you would always want to draw a diagram. So I will draw a right triangle because trigonometry usually only works on right triangles. Measure of angle G is 90 degrees, so we know since this is the right angle, we know this is angle G, and FG is 3, and it doesn't really matter which is F and which is H. FG is 3, and tan of F is 4 over 3. So now we know tan of F is opposite over adjacent, right? And we know adjacent right here is 3. So the ratio of tan of F is actually 1 to 1. So 4 over 3 equals, let's say let's call this G of H over 3. So since it is 1 to 1, we can just match the 4 with G of H. So G of H actually equals 4. So G of H is 4. And now they want to know the length of FH. And if this triangle is familiar, this is what's called triangle triples. And there are certain triples, for example, like 5, 12, 13, right? And this is also a common triple, 3, 4, 5. Instead of doing the Pythagorean theorem, which might take a while, which would be 9 plus 16 equals 25. That might take a while to do. So instead of doing that, we could just memorize some of these triples that are common. And since we know that 3, 4, 5 is a triple, that means 5 is the length of FH. All right, number 5. In triangle ABC, the measure of angle C is 90 degrees and AB equals 26. If sine B is 5 over 13, what is the length of BC? So let's draw another diagram. ABC, the measure of angle C is 90 degrees, so we know C is right here, and A can be here. AB equals 26. If sine B equals 5 over 3, so sine B is 5 over 3, what is the length of BC? So they want to know this length. So when it says 5 over 13, that is, what is it, opposite over hypotenuse, correct? So since it's opposite over hypotenuse, we can write 5 over 13 equals opposite, which is over here, let's call this AC, over hypotenuse, which is 26. So now we have this proportion, and now what we could do is multiply on both sides. We could cross multiply and then figure out AC. However, we know that 26 is twice the number of 13. So what we could do is actually multiply 5 by 2 and get AC, which is 10, right? So now we know this value is 10. So it says, what is the value of BC? How do we know that? We actually discussed before that there was a triple 5, 12, 13, right? And we see that there is 5 and 13 in the sine value, right? However, we don't see that in the triangle. This is because if you multiply all of these numbers by 2, you get 10, 20, 4, and 26. And this also works. Same goes for 20, 48, 52. Right? This also works. These all works as triples as long as you multiply all the sides by the same number because those are all similar triangles, right? So since we have 2 out of the 3 side lengths in this triple, 10, 26, and we're just missing 24. So 24 would be our answer. All right, number 6. Triangle LMN has right angle M. If cosine L equals 3 over 5, what is the value of sine N? So we know, if we draw a diagram here, LMN, right? Angle M is a right angle. So instead of saying it's a 90-degree angle, it says it's a right angle, which is basically saying the same thing. So we know M is here, and then we can draw L and N. If cosine L is 3 over 5, since we don't know any side lengths, we can just use 3 over 5 as 1-to-1 ratios of the side length because Any similar triangles will have the same trigonometric value if you get cosine L, even if it's like 6 or 10. So yeah, we can just do adjacent over hypotenuse, which is adjacent, which is right here, and then hypotenuse is over here. So now this looks very familiar to the question we did before, except we had 4 over here. So now we know the side length of MN is 4, right? However, that is not actually necessary because this question is asking what is the value of sine n. Sine n actually only cares about opposite over hypotenuse, right? So it only cares about 3 over 5. So the answer is 3 over 5. There is a pattern in remembering this. Let's say M is the right angle. So if there is a right angle here, right? That's the right angle. And the sine of theta, let's call that L. For example, if L is theta, sine of theta is equal to the cosine of 90 minus theta. And 90 minus theta would just refer to the other non-right angle, because since we know that M is a right angle, that means L and N have to add up to 90. So if angle L is theta, that means angle N has to be 90 minus theta. And this is a pattern that you should remember, and this might come up, and this could save you a couple seconds of time. In triangle ABC above, the sine of y degrees is 0.8. What is the cosine of x? So y is 0.8. Instead of writing it as 0.8, we could write it as 8 over 10, or that's also equal to 4/5. So the sine of y is 4/5. What is the cosine of x? So as I said in the previous problem, sine of theta is equal to the cosine of 90 minus theta. In this case, sine theta is y, and that's equal to cosine 90 minus theta, which is the other angle, which is x. So they are equal to each other. So the cosine of x would be 4 over 5. In the figure above, triangle ABC is similar to triangle DEF, and angle B is equal to angle E. What is the value of tan F? So now we know that these two triangles are similar. That means the angle measures are the same. Not necessarily the side lengths, but the angle measures are the same. What is the value of tan of F? So we know that trigonometry is written in ratios. So tan would be opposite. In this smaller triangle, tan would be opposite, which is DE, over adjacent, which is DF. However, since we know that this ratio, because this is the same angle, say this is 30 degrees. If this is 30 degrees and this is 30 degrees, tan of 30 degrees would have the same value, right? So that means opposite over adjacent would also be equal to opposite over adjacent, which is equal to 5 over 12. So the answer is A. In the figure above, cosine D equals 4 over 5. If CD equals 16 and DE equals 10, what is the length of BC? So I like to label the triangles before we do anything. So cosine D is 4 over 5. We can't really label that. CD is 16. And DE equals 10. What is the length of BC? So they want to know the length of this. So now we're working with similar triangles here. So cosine D, which is right here, which is adjacent over hypotenuse, is 4 over 5. So we know adjacent, the value of adjacent is 16. So 4 over 5 equals 16 over hypotenuse, which is AD. So we know 4 times 4, if you multiply by 4, you get 16. So what we could also do on the bottom is multiply 5 by 4. So AD equals 20. So now we know this big one is 20. That means this length is also 10. So now, since we know that, we can figure out the other side length. Now we could actually do similar triangles. So we know that smaller, let's draw two triangles. So I'll draw the bigger one here. 20, 16, and unknown third side length. We know this side is 10. And we don't know the top. We don't know what 16 corresponds to on this smaller triangle, but we do know that 20 is actually double 10. So 16 should also be double this side length. So 16 divided by 2 is 8. So we know that the bigger triangle is 2 times as big as the smaller one. So now, since we know that this angle, let's say x, let's call this one x. If the bigger side length is 2x, right? That means this is also x, right? That means these two side lengths are equal to each other. So if we just figure out the smaller triangle side length, we can get the length of BC. And we know the ratio 3, 4, 5, right? This also corresponds to 6, 8, 10. And also 12, 16, 20, which is present here. So we know that this side length is 12. But we are focusing on 6, 8, 10. So we know that this length is 6. And so that means x equals 6 or BC equals 6. In triangle DEF, the measure of angle E is 90 degrees. So let's draw a diagram right away. E is here. D and F are here. DE equals 12, right? EF equals 16. Triangle LMN is similar to triangle DEF, where vertices L, M, and N correspond to DEF respectively. All right, so this just means that the order of the letters that are saying it, so D corresponds to L, meaning those angles are congruent. So D is congruent to L, E is congruent to M, F is congruent to N. So in this case, we know that M is actually the right angle. I'm gonna draw a smaller one. And so each side of the triangle length is 2/7 the length of the corresponding side triangle of DEF. What is the value of cosine N? So we don't actually need to find out the side length values of LMN in order to find the cosine of N, because we know that the cosine of a certain degree, if they are the same, it's the same answer, right? So let's just figure out this cosine of F on the bigger triangle. So we know adjacent is 16, right? And in order to figure out this, we know that the ratio is 3, 4, 5, because if we multiply it by 4, we get 12, 16, and 20. And just a side note, the greatest number on the triple should be the hypotenuse, okay? And so we know that this side length is 20. So now we know cosine of F is 16 over 20 because it's adjacent over 20, 16 over 20, or that's equal to 4 over 5. All right, so now we're going to do additional trigonometry topics, practice questions. So if x plus y equals 90 degrees and cosine of y equals 7 over 13, what is the value of sine over x? So we discussed this before. Sine theta is equal to cosine 90 minus theta. And this also works the other way around. So that means cosine theta is equal to sine 90 minus theta. So since cosine of y, and we know that they both add up to 90, so that means we know that, for example, y is also equal to 90 minus x, right? Cosine of y is equal to 7 over 13. What is the value of sine over x? Since x and y are here, they're different angles. Sine of x is also 7 over 13. Just see. If sine of n equals 3 over x and x is not 0, what is n in terms of x? So x is not 0 just means that it's not undefined. What is n in terms of x? In order to solve for this, we need to learn about inverse sines, or inverse sines, inverse cosines. So we know So what the thing about inverse sines is if it's sine to the power of -1, that means if you put the ratio, if you put like 4/5, it'll pop out the degree. It'll pop out the degree. And this is something that you can do in your calculator, right? So if sine is n, sine of n is 3/x, we can just do actually sine inverse sine of n. And this looks kind of unorthodox, but these two signs actually cancel out and you get n equals sine -1 3/x. Sorry, it's a. In a right triangle, one angle measures w, where sine w equals 5/13. What is cosine 90 minus w? So we know that sine of theta is equal to cosine 90 minus theta. That's the same with angle w or any angle in general. So sine of w is 5/13. So cosine 90 minus w is 5/13 too. If 2 tan b equals 3n over 4m, what is b in terms of m and n? That was a little confusing, but first thing we could do, we could get rid of this coefficient in front of the tan b. So we could go divide by 2, and that would become, if you do it times 1/2 on both sides, it would become 3n over 8. You add multiply 2 to the bottom. And then you get tan b. If you inverse tan b on both sides, you do get b equals tan -1 3n over 8. So the correct answer is D. All right, number 5. In the triangle above, the cosine of t degrees is 0.35. What is the sine of n degrees? So again, they're asking for opposites, cosine and sine, of two different angles. So we know that the answer is the same. The ratio is the same, so the answer would be 0.35. If sine 90 minus x is n, which of the following must be true for all values of x? So in this question, this again, furthermore, enforces the idea that sine 90 minus theta equals to cosine, or vice versa. And this again, we just substitute theta for x and we get the same thing. And n, if they're equal to each other, you could just put them equal to each other. So the answer is A, because cosine of x is equal to sine of 90 minus x. If cosine of x degrees over 4 equals n over 8t, what is x in terms of x, n and t? So we're solving for x, so we just need to keep that in mind. What we could do is actually multiply 4 on both sides to get 4n, cosine x equals 4n over 8t, which is equal to 1, which is equal to just n over 2t. And if we do inverse cosine on both sides, you get x equals inverse cosine n over t, n over 2t. Oh, there we go. The angles shown above are acute, and sine of x equals cosine y. If x equals 3z plus y 5 and y equals 2z minus 10, what is the value of z? So we know that the angles above are acute, so they're less than 90, and sine of x equals cosine y. What does that mean? That means that these two add up to 90. Reason being, if they're equal to each other, this kind of looks like what we learned before, this thing. So if we do, let's say we want to keep x, sine x, we would also know that cosine equals to of 90 minus x is equal. And we know 90 minus x equals to y. 90 minus minus x equals y. And sorry, I don't know why I put y there. And if we add x to both sides, we go 90 equals x plus y, which is this. And so since we know x plus y equals 90, we could just add x and y in terms of z. So we could do 3z plus 5 plus 2z minus 10. Then this would equal 90. So we'd get 5z minus 5 equals 90. 95 equals 5z. And if we divided 5 on both sides, we get 95 over 5, which is z equals 19. 19. If n degrees equals inverse cosine 1 over rad 2, what is the value of n? So we were trying to find for degrees in this case. So now we know the ratio adjacent over hypotenuse is 1 over rad 2. Let's actually get rid of that. Let's get rid of the rad. Let's say we did rad 2 on both sides. Then we get rad 2 over 2. And this is very interesting because there is a chart that I will show you in a sec real quick. Okay, so if we take a look at this chart, we can see that if we try to match a rad 2 over 2 into a cosine because of this inverse cosine, it actually shows rad 1 over rad 2, which is right here, which is 45 degrees. So we know that 45 degrees is the value of n, so the answer is 45. This chart you should be able to memorize, especially the sine, cosine, and tangents. These ones are not really that important because you just know that cosecant, secant, and cotangent are just the reverse, the reciprocal of sine, cosine, tan. So the answer is 45 degrees. Number 10, in triangle NOP above, point K, not shown, lies on NP. What is the value of cosine KOP minus sine NOK? So let's just draw a point K. Let's draw it right here. So that we can create angles KOP and NOK, which is right here. So they want cosine. So, okay, we know these two angles add up to 90, right? So we do know we need to keep this in mind. Sine x equals cosine 90 minus x. So cosine KOP, let's call this angle theta. This is 90 minus theta. It means cosine theta minus sine 90 minus theta. Since they are equal to each other, subtracting them from each other would just make them 0. So the answer is 0. So yeah, that's all the trigonometry practice. If you would like more, please just subscribe and comment and let me know. Thank you.